All right, guys, welcome back to yet another episode of DSA Python series. And my name set the context for today's video. Today we will be talking about more about linked list. We have already started our linked list, right? And we have seen insertion, okay, or append. We did append function, right? So now today we will be going for delete function. Okay, let's try and understand what delete function looks like and how we can uh, do it using linked list. Okay, so without any further ado, let's get started. Okay, give me some time. Linked list. Um, can I get some sort of canvas, different canvas? How to delete uh, 0 and 7. How to delete BS. Why it is not coming? Okay, let us just delete everything and what is deletion in a linked list? Okay, this we will be doing. So before we do deletion, we should learn about what traversal is, right? So this is it. Traversal in a linked list. Okay. So what is traversal? Traversal is just like you will start from the head and you will end uh, where the current dot next is none. Okay, that is what the traversal in the whole linked list means, right? So how do we do that? So simply we will define a traversal, okay, and then we will see the condition that if self dot head is none, then let's say our string is empty, okay, or you can say our linked list is empty. So we will simply say that if self dot head is none, then we will simply print our singly linked list is empty, okay. Otherwise, what we will do, we will traverse, right? So in traversal, we will simply do current is equal to current dot next, okay. And in the while condition, we will put if current is not none. So if current is not none, it means that there is an element in the singly linked list, and that if that element is there, then we will just print the value of that current element, right? And we will increment one by one just to print and to see the how traversal is done, right? So let's do that. Okay, so the thing is, what we will do, we will first, okay, so first is we will do if the linked list is empty, okay. It is wrong. Okay, so yeah. So if the linked list is empty, then we will go for putting the condition self dot head. If this self dot head is equal to none, then we will simply print some statement. Okay, and if it is not none, if it is not none, then we will print the whole linked list, right? So with while statement. Okay, this is how we will do, right? Let me just create a link. Okay, so let's do the traversal wala question. Okay, let me just see where this traversal is. We have okay. So okay, so let us do before this. Okay, I will do traversal. Traversal. Traversal is simply you have to start with a while loop. Okay, let's say inside the def function while I just have to say while my current is not none. Okay, if my current is not none, then this loop will run, right? So it will print okay, so it will print the linked list is, or you can say simply it will, we will make it every time it will print current. Okay, so it will start printing current, and we can put comma also, right? We can put that, or we can have some space. Okay, so when we are printing this current is an object. We actually have to print the value of this object. Okay, so it will be like this, current dot value and comma, and so that there is space when traversal is happening. Okay, and we will print current, current dot next. Okay, so when this traversal happens, then it gets printed. What if the linked list has only one, or say mm, when linked list is empty? Okay, so we will just put a condition before this, that will be our edge case. So edge case will be if let's say I'm talking about my linked list, and it's if it is empty, it means that it doesn't have a head, right? If the singly linked list is empty, then that list is not having any head. So if self dot head is equal to none, okay, if this condition is there, then I'll do, I'll simply print the singly linked list is empty. I'll do that. Simply it will print the singly linked list is empty. And according to this, we have this current. Okay, so I will just assume some variables, right? I'll assume some variable. I'll simply say that current is my variable, right? And I will define the traversal, right? So I'll just define here. If I'm defining this traversal, I have to think about the function traversal, and it will take the value self, right? And all this will be indented. So all this will be inside this function def traversal. Okay, so this is how we can easily uh, traverse through the linked list. Okay, little bit of tricky, but if you solve it 1 to 3 times, then it will get into your head. Okay, in the end we just have to do current is equal to current dot next, so that again this current dot next. So this is assuming the value current, the current dot next is value. So every time it is going, it is checking, okay, whether my current is not none. If it is not none, then only it will print the current dot value, right? Current dot value. Okay, so that is how traversal is happening. I'll just comment it out. Okay, now we can solve how the deletion is happening. Okay, so what can be the idea of deletion? If some deletion is happening, it means that what I'm doing is I'm just let's say this is the thing. Let's say this is the okay. Let me just create some linked list. So this is one. Okay, this is two. This is three. This is four. Okay, so this is all the linked list is, right? Okay, so this is our node, right? This is the head. First node is the head, and these are all other nodes, right? So this is address, right? And this is my value. Okay, this is val. Okay, so val can be 5, 7, 9, 10. Let's say if I want to delete this node. Okay, if I want to delete this node, then what I'll do, I'll simply, so basically the concept of this node is where is it? Whenever this node is basically some address which is coming like this from the previous node. Okay, so let's say it then this is my 0, this is 1, this is 2, this is 3. So second node I want to delete. Okay, let's say its address is 488. Okay, so second node address is 488. It means that here I will have the value just remove this. Okay, so here I have this value 488. Okay, so this 488 corresponds to the next node. Okay, so if I want to delete this node entire node, it means that I have to do just one thing. This 488 address I have to remove, and let's say the address of node 3 is 562. I just have to rewrite this 562 here. So what it will do, it will correspond to this node directly. So this node is deleted. Okay. And you will ask, sir, what is this node? This is also pointing, no? So it doesn't have any value. Why? Because this is the one side point. Singly linked list is, this is pointing towards left. Okay. So it has got no value because there is nothing coming from the end. It is just an independent node which doesn't exist, right? It means that the singly linked list, the architecture is such that this node is pointing directly here. It means that the final node will be 0, 1, and third number node that will assume the value of 2. That's it. So it will directly shift here. Okay. And this original node 2 will be out of question. Okay. So that is the concept behind the deletion of node. Deletion of node from singly linked list. Deletion of node from singly linked list, right? So that is how it goes. Okay, so this is the question we want to do. 237 number lead code, and it's a medium level question. Okay, so we have to be very careful. So this, let us read this question. There is a single linked list head and we want to delete a node in it. Okay, you are given the node to be deleted. You will not be given access to the first node of head. Okay, so these are some condition कि you are given the node to be deleted. So node, we know which node is to be deleted, right? The other thing is you will not be given access to the first node of head. Okay, so first node we don't have any access. Okay, I'm sorry. Okay, so this is our first node. Okay, let me just draw it on screen. Okay, so this is the list, and right, this is the linked list. Okay, so this is 0, this is, let me just change. So this is 0, this is 1, this is 2, this is 3, and this is 4, right? So these are all the linked list. These are the indexes. These are all the indexes, right? And let's say I have this node 5, 7, 10, 12, 15, right? These are all my, and this is address, let's say 488, 488, 572, 572, 893, this is 893, and 1146, 1146. Okay, so this is what, this is actually the thing which is pointing in this direction, right? Like this. Okay, so this is how the node is pointing. Okay, okay, now let's try to solve this question. All the values are okay. So this So this node we don't have access to, right? So this node, mm, so this node we don't have access. Okay. Okay, so let us write it no access. So this is, there is no access of this for this node. This is given in the question, right? All the values of the linked list are unique. So we have taken all unique values, right? All these 7, 10, 5. Okay, these are all values, right? And it is guaranteed that the given node is not the last node in the linked list. Okay, so you it is pretty sure in the question that the given node is from the middle. Okay, so let's consider that this is the middle node which we have to delete it. Okay, this is the node which we need to delete, right? This node is to be deleted. Okay, we need to delete this node, and it is pretty sure. Okay, wait, it is pretty sure that the node which is to be deleted is not the last node. This is given. Okay, this is given in the question that situation is this, right? It is not the last node. Okay, all the values of linked list are unique. Yes, and it is guaranteed. Delete the given node. Note that by deleting the node we do not mean removing it from memory. Okay, so deleting is not that we need to remove it from memory. The value of given node should not exist in the linked list. This is what I told you, that we just have to change the address of the previous node so that it doesn't correspond to that 2 number wala node which we want to delete it, right? So 2 number, this is the index. So this we want to delete it, right? 2 number wala node, this we want to delete it. Okay, the number of nodes in the linked list should decrease by 1. So number of nodes should decrease by 1. All the values before nodes should be in the same order, right? So when you make the arrow like this, okay, let's say from here to here, okay, this will be your linked list. So this 2 number linked list is gone, right? This 2 number linked list is gone. So all the values before node should be in the same order. Yes, we are just changing this link. So before this, whatever is the order, it will remain constant, it will remain the same. And all the values after node should be in the same order, right? So this will also be in the same order, right? For if there are some other nodes, then also it will be there. Okay, so this is none. Okay, so this linked list is getting finished. It means that this address will be none. That is why this will not correspond to any other node, right? So this has to be none if this is the last element. So the last element, the last element of the singly linked list must be none, right? Or you can say the last address of the last address of last element, right? So what we will do, what concept you can use here, what is coming to your mind, what should be my funda to use here. So we have seen how traversal works, right? So here we have already seen how this traversal is, we can work on this. So what we will do, we will do the traversal. Okay, so let's see the example also. So custom testing node should, all the values after node should be same on it. कस्टम टेस्टिंग क्या बोल रहा है, फॉर द इनपुट यू शुड प्रोवाइड द एंटायर लिंक लिस्ट. ओके, या head and node to be given node dot node. Okay. Should not be last node. The list. Okay. So let us brainstorm it. What the question is saying. So I will just write this, delete the node in a linked list. Delete code to 37. Delete code to 37. Delete the node in a linked list. Okay. Okay, so this is lead code 237. राइट, थोड़ा बड़ा कर सकते हैं. Okay. Okay. So my logical goes like this. I just have to change the address as far as this deletion is concerned. But before that, I have to traverse and I have to see that my my number, or say my node in the linked list is found. If that node is found in the linked list, then I will think of going back in the position, okay, in the linked list, and I'll try to change the address of that linked list. Okay, so before that I need to have an address of the linked list uh, in the forward direction also, right? So I need to have address of this linked list, and I need to put this address, okay, this address here, right? Here I have to put the address. Okay, then only this list can be removed. As far as my understanding says, this should be done, so that the order of previous linked list will remain the same, and the order of the post the later uh, nodes which are there, which are present in this linked list, will be same. Okay. The order remains conserved, right? So let us first start traversing, right? Let us do the traversal. Okay, and now one more thing is there. We will not be able to access this head. Okay, so that is also the condition. Okay. Mm, 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 mm. Okay. So it means that I have to start from first element, right? So my while loop or for loop will start from first element, okay, and we will traverse. Okay. So yeah. So we don't have to return anything. We just have to modify the node in place, right? In place we have to do. Okay. So custom testing for the input, you should provide the entire linked list. Okay. And the node to be given node. The node should not be the last node of the list and should be actual node in the list. Okay. We will build the linked list and pass the node to your function. Okay. The output will be entire list after calling your function. So output will be the entire list. Mhm. 45194. Okay. So this is the given node. Fifth number node we have to remove. So input had 4519, node is equal to 5. It means that the value of node will be given to you, right? And we have to remove that 5 from the output, right? So you are given the second node with verify the linked list should become 419 after calling. Okay, so I have to create a function for deletion, right? And this deletion will have uh, self, then the node which is to be deleted, right? This input has to be there, right? Yes. So I have to create that function, and whenever somebody uses that function, and mm, it will just give that node as the input. Uh, so that element, that node will be deleted entirely from the linked list, and the linked list will be printed without that element. So this is supposed to be the answer, right? So this is how the now let us talk about some constraints. The number of nodes in the given list is the range 2 to 1000. Number of nodes. Okay. And value of node is like you can take numbers from minus 1000 to plus 1000. That's it. The value of each node in the list is unique. Okay, it is given. The node to be deleted is in the list and is not a tail node, right? It is not a tail node. It is from the middle. This we have already discussed, right? Okay. All right, so this is the node, and we have to remove this second element, let's say. So we have to traverse it. We have to know that I need to, delete so and so value is already given to you, right? Node value. Okay, so this is how we have to do. Now, how do you do that? Okay, so firstly, we can start the traversal, and we will see whether uh, if that node is coming, right, current. If the current dot next, we actually have to assume, let's say we assume uh, two variables. One variable, let's say previous, and the another variable, let's say current. Okay, uh, let's start writing the code, and we will just see where we are going wrong. Delete node. So simply I have to print, right? I have to print that, print current dot. So I will just say if current dot next, if current is equal to this node value, right? Whatever node is given, this is equal to node dot val, right? So if current dot val is equal to node dot val, then what I'll do? Mm, okay, so how to get the address of so I have this current dot val. How do I go back? Uh, how can I go back? Let's say if I am at current node, how can I go back or get the node value of previous node in simply linked list? Let's say Python current is this, so you can easily go forward. Current dot next se to we go forward. Okay. Okay, so current dot, because a node in single list only stores this, but there is no current. We cannot go back. Yeah, because it is in one direction. It is not on previous node. So how will we get while previous dot next is not keep? Okay. So what we will do, we will just uh, keep previous every time. We will have to. That is why I told you ki we have to take one variable. We have to assume two variable. One will be current and one will be previous. So we will, every time we traverse, we will update the value of the previous, right? So that is something we have to take care, right? Okay. So initially we will assume previous is equal to none and current is equal to head. So previous is equal to none, current is equal to head, right? So we will see that if current dot next is not none, current dot next is none. Okay. For I in range 0 to n, or let's say 1 to n, n is equal to ln of. Do I know the length of the linked list? how to get length of the single linked list. So from head to none, maintain a counter. Okay. Can we use for loop in single linked list? Using for loop, how do you do for I in range 10? Best way make your node iterable. You can define class node define inet self current is equal to self while current is not. For your DSA constant with while. That is what we cannot find out. It's little difficult to use for loop. Okay. Okay, deletion of node. It will obviously be O of n na, because we have to traverse through the loop. Okay. Worst case will be O of n. Okay. We can you can have, because you are traversing through the loop. Let me log in. So it will be O of n in the worst case in doubly linked list. It may be O of 1 if you have a reference pointer. Okay. So for loop idea is will not gonna work, right? So let's think something else. Okay, how we can do that? Let us assume a temporary variable which will be self dot head. Okay, and we will traverse so I will just write temp is equal to self dot head. Okay, temp is equal to self dot head. Okay, after that I will just assume I will just put an if statement if temp dot next, if temp dot next is not a null. Okay, so temp dot x next is not null, right? So I have just assumed the temp as the head, and temp dot next if it is not none, right? So if it is not none, then if temp dot value is equal to val. Okay. Then we will say self dot head is equal to temp dot next. Okay. So if temp dot next is not none, if temp dot next is not none. Okay. Then I will say if temp dot val is equal to val, then I'll put self dot head is equal to temp dot next. Next. Right. Else में मैं डालूंगा कि फाउंड इज इक्वल टू फॉल्स अगर है तो प्रीवियस इज इक्वल टू नन हो जाएगा. Else found is equal to false, previous is equal to none हो जाएगा. Right. Then I'll start the condition while temp is not none. Right. So I'll just start traversing. So it will be while temp is not none. So cell dot head is temp dot next. इसमें we will just return. Okay. And if while temp is not none. Okay. While temp is not none. So if temp dot val is equal to val, right? So found is equal to true, then break. Then we will have previous is equal to temp and temp is equal to temp dot next. If found, previous dot next is equal to temp dot next. If found, previous dot next is equal to temp dot next. Then I'll just return else. I'll just print node not found. Can you just execute it? Oh, this is very tough question. Very tough, very tough. I think we should again revise everything like from basics of single English because little bit of confusing is there. Okay. Right from insertion, then traversal, then how to create a node and all those things. We just have to revise it once again. Okay. So that we have a grasp of this and deletion of a node is very difficult because these conditions they have given, right? These are the conditions which mm, and you will not be given access to node of the head. So that is why this simple question is getting tougher and tougher. Okay. So delete node in a linked list, which all companies have asked. Delete node in a linked list. And this is lead code 237. Lead code 237, which companies have asked. See, you can see here companies reported on 237. Okay, starting list. Google, Amazon, Microsoft, Apple, Adobe, Cisco, Oracle, PayPal, Qualcomm, VMware, and Nvidia. Okay, there is also historical Microsoft tagged. So in GitHub and a Google question. Database currently lists to the design of Google associated questions. So this is FANG job preparation wala some roadmap is given. You can see here some roadmap is there. Okay. So these are all Google tagged question. Guess the word, expressive words, stacks, logger. Right? Okay, so this question is good. It's been asked in various good product based companies. Yeah, you should know this. And there is some runtime error is coming. Let us check why it is coming. Let's check. You are mixing two different English deletion. Okay, something. What logic I'm doing? So the problem is we have this key problem because we don't have access to the previous node, so we cannot do this usual Python thing, previous dot next is equal to node dot next. That is the problem which we are seeing here, because here we are doing this, right? Okay. So instead we should copy the next node value into current node and skip the next. Else we can simply do node dot val. Okay. It will be equal to node dot next dot val, and node dot next is equal to node dot next dot next. 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 Oh my goodness. Written by copying the next node's value. So previously we were doing where we know actually what our head is, but here we have this limitation that you don't know the head, right? So when you don't know the head, you cannot play on the head part, right? So whatever is the node dot value, that will, so whatever is our node value, okay, that we will copy. So let's say my node value is 5, okay. So what I'll copy the next node ka value into my node value, okay. And after that I will do node dot next, right? Uska I will do this node dot next. Simply I'll just copy the node wala uska object, right? So in this way, it will be easy for me to preserve the order also, right? It was sort of, very tricky question, right? Okay, so these question we will do tomorrow, right? Some 2 3 question we will try to complete. Okay. So that is how all here you can see all 41 test cases have passed, right? And the time complexity here is only O of 1, right? So perfect efficiency achieved, no changes needed, right? So with the conventional method, we were supposed to do, uh, you know, mm, the traversal also, right? So in traversal, we could have achieved the time complexity as order of n in the worst case scenario. But here, what we are doing is we are directly taking the node value and we are copying the next node value to the present node value. Okay, and then we will be copying the next node value to the next वाला node value, उसके next वाला node value we will copy. So likewise we have done this, right? So it will have a time complexity of order of 1, that is constant time complexity, right? So that is how we can do this question. It was sort of, tricky question, I would say. It's a medium level question, but in just 2 lines of code we could achieve this, right? So uh, that's a good part. Okay. So tomorrow we will see how we can do the counting of nodes, then how we can search in the linked list, and how we can design a linked list, right? So we'll see tomorrow. Okay, tomorrow by 11 p.m., right? So I'll be there again with these questions, right? Okay. So see you. Good night and bye bye. Take care.